Have you heard about artificial neural networks and how they work compared to our human biological systems? Let's take the example of human beings recognizing images and how this compares to the world of artificial intelligence. So let us embark on a short journey to explore how both biological and artificial neural networks tackle this task, using the example of recognizing a car wheel. We'll discover their similarities, differences, and unique strengths. The human brain. Our adventure begins with the human eye. Light enters and strikes the retina, where special cells convert it into electrical signals. These signals travel through the optic nerve, reaching the primary visual cortex in the back of the brain. Here, the brain starts piecing things together, processing basic features like edges and colors. Next, the information journeys to the secondary visual cortex. This is where the magic of pattern recognition happens. Here, the brain assembles the puzzle pieces, identifying the shape and features of the car wheel. And just like that, our brain has successfully recognized the image. Now, let's see how an artificial neural network approaches the same task. The artificial neural network. Imagine a sophisticated network of interconnected nodes, mimicking the structure of the brain. This is an artificial neural network. Its journey begins with sensors in an artificial eye capturing the image of the car wheel. This raw data is fed into the network's first layer, the input layer. Think of the input layer as a giant grid, where each node represents a single pixel in the image. These nodes then pass the information on to the next layer, called the hidden layer. This process of moving data through the network is known as forward propagation. Inside the hidden layers, the real work of pattern recognition begins. One layer might focus on detecting edges, while another identifies the circular shape of the wheel. Each node performs calculations, analyzing the data and passing the results on. Once the network produces an initial guess, it compares it to the correct answer and calculates the error. This error is then used in a process called backward propagation, where the network fine-tunes itself by adjusting the connections between nodes. Through countless repetitions of forward and backward propagation, the network gradually learns to recognize the image with increasing accuracy. Finally, the output layer confidently identifies the object as a car wheel. But artificial neural networks can go even further. With vast amounts of training data, they can not only recognize but also classify the wheel, pinpointing the make and model of the car, providing detailed information beyond simple recognition. Back to the human brain. The human brain, however, is far more than just a sophisticated image recognizer. It connects what we see with a rich tapestry of memories, emotions, and even future thoughts. The processed information travels to the association areas in the temporal lobe. Here, the brain works its magic. It matches the features of the car wheel with stored memories, not only recognizing the object, but also potentially triggering a cascade of emotions and ideas. For example, seeing a car wheel might remind you of a childhood road trip, evoke feelings of excitement, or inspire you to plan your next adventure. This entire process happens in a blink of an eye, showcasing the remarkable power and speed of the human brain. The power of efficiency. While artificial neural networks excel at complex computations and detailed information retrieval, they have a significant drawback: energy consumption. Training and operating an artificial neural network can require vast amounts of power, sometimes thousands of watts. In contrast, the human brain operates with incredible efficiency, consuming only about 20 watts, roughly the equivalent of a small light bulb. This remarkable feat allows the brain to perform complex tasks, learn continuously, and spark creativity, all with minimal energy expenditure. Artificial intelligence is a powerful tool, achieving remarkable feats in the realm of image recognition and beyond. However, the human brain remains a masterpiece of nature, unmatched in its efficiency, complexity, and ability to inspire. It's within the vast expanse of our thoughts and memories that we discover the true power of the human mind.